Good morning, students. Today's topic is standard signals. Okay. So listen, students. So in previous class we have studied about the introduction to signals and system. Correct? Okay. So now we are going to see some standard signals. Okay. So before that, you recall what is signal. What is signal? Any physical quantity that conveys some information. You know that any quantity that is conveying. If you are taking TV, means it is conveying the video signal. So through the video we are getting some information. So any physical quantity that conveys some information is called a signal. Okay, so this varies with respect to the independent variable. So what is independent variable? If you are taking a function x of t, means xt is the independent variable and x is the dependent variable. Okay, so recall this, and next we can see some standard signals. Okay, so before going into standard signal, let us know about the continuous time signal and discrete time signal. So in the introduction part itself, I said you about the continuous and discrete time signal. So what is continuous time signal? The continuous time signal will defined for all the values of the t. That is, it is continuous in nature. Okay, this will be in continuous in nature for all the values of t. For t, when t is equal to 0, when t is equal to 1, or when t is equal to 1.2, 1.3. So for all the values there will be some information, there will be some value. Okay, so that is the continuous time signal, and the important thing is it is represented by x of t. Okay, t is the continuous time signal. And next is the discrete time signal. So what is discrete time signal? It will be discretized in nature. Only for a particular value it has the information. Okay, so for 1 there is some value. Okay, so for 1 there is some value, and for 2 there is some 2 value, and for 3 there is 3. Okay, so for particular value only we get the information, and for 1.2 there no value is predicted there. Okay, so for continuous, for each value we can say that we can get the information or we can predict some values. Can you understand? Okay, so discrete time signal can be represented in x of n. Okay, so for discrete time signal, you can take the example as the population, as I said in the introduction. So please go through that introduction video. Okay, and now we can come to the standard signal. So the first standard signal is the unit step function. Okay, the first one is the unit step function. So what is unit step function? So unit step function means, so before going into unit step function, first you should know about the step signal. Okay, so what is step signal? The step signal is defined as the continuous signal x of t equal to a. The amplitude value is equal to a. That is, for x of t, the value for 0 to, that is t greater than 0, less than, greater than or equal to 0. That is, this is 0. So these lines are the greater values of t. So t greater than or equal to 0, the amplitude value is equal to a. So this is the step signal. For less than 0, the value is 0. For greater than or equal to 0, the value is a. Can you understand? So this is the step signal. That is, for t greater than or equal to 0, the amplitude value of x of t is a. For less than 0, the amplitude value is equal to 0. I think you can understand. And next we can see the unit step signal. So next is the unit step signal. Okay, so unit step signal, this is for continuous time signal. How we are saying it is a continuous time signal? Because it is u of t. And this is for discrete time signal, and discrete time signal can be represented as u of n. Okay, so u of t value is equal to 1 for t greater than or equal to 0. And how you can represent the so u of t is equal to 1 for t greater than or equal to 0. So this is 0 value, and for t greater than or equal to 0. So the greater values of 0, the u of t value is equal to 1. Okay, so this u of t value is equal to 1. For all greater values of t, this u of t value is equal to 1. So the unit step function can be represented as in this form. Because in the step function we see earlier that what is step function? S in x of t is equal to a. Okay, that is, here the a value now is equal to 1 because x of t is equal to a for t greater than or equal to 0. Okay, a greater than or equal to 0 and 0 for t less than 0. Same thing only. So unit step function. What do you mean by unit 1? Okay. So this is a step function. So for unit step function, we are noting as, so here u of t is equal to 1 for t greater than 0 and 0 for t less than 0. This is for continuous time signal. And for discrete time signal, the u of n value is equal to 1 for n greater than or equal to 0 and 0 for n less than 0. So how you can draw this signal? This is u of n value and this is the n value. So what is the value? N. I said you discrete time signal is a discretized value. Want to notify as a discretized value. So it is 0 and this is 1 value and 1 for n greater than or equal to 0. So you want to mark it as in the discrete form. So for all values t greater than or equal to 0, the discrete value is equal to 1. Okay. 0, 1, 2, 3, 4, 5, 6. Okay. Here also 1, 2, 3, 4. For all values continuous time signal, here the value is 1 and here for all discretized value, the value is 1. Okay. So the next signal is the unit ramp signal. So the unit ramp signal can be represented as R of t or R of n. Okay. So previously I have seen the step signal and unit step signal. For unit step signal, the amplitude value is 1 and for step signal, the amplitude value is a, which may vary. So it is only applicable for t greater than or equal to 0. Next is the unit ramp signal. So the value of unit ramp signal is R of t is equal to t for t greater than or equal to 0. See, for t greater than or equal to 0, the value of R of t is t. That means, so for 0, when t is equal to 0, R of t value is equal to 0. When t is equal to 1, R of t value is equal to 1. Okay. When t is equal to 2, R of t value is equal to 2. In this one. So when t is equal to 3, R of t value is equal to 3. When t is equal to 4, R of t value is equal to 4. So when t increases, R of t is also increases. Okay, when t increases, R of t also increases. And next for discrete time signal. So for discrete time signal, the value of R of n is equal to n. Okay, so for 0, the R of n value is equal to 0. For n is equal to 1, the R of n value is equal to 1. So for n is equal to 2, the R of n value is equal to 2. For n is equal to 3, the R of n value is equal to 3. So here when n is equal to 1, R of n value is equal to 1. For n is equal to 2, R of n value is equal to 2. For n is equal to 3, R of n value is equal to 3. Likewise, it is increases. So this is the unit ramp signal. So it is the unit ramp signal. That is, for if t is equal to 1 means R of t is also 1. Okay. So the same representation is for unit ramp signal. If suppose the R of t value is equal to a into t means the value is t greater than or equal to 0, 0, t less than 0 means what will be the graph representation? When t is equal to 0, a into t 0. And when t is equal to 1, the value is a into the value a may be, it may be 1 or 2, the amplitude value. So in unit ramp signal, the a value, that is the amplitude value is equal to 1. Okay. So in other representation, if a is equal to 2 means R of t is equal to 2t. So t greater than or equal to 0. If t is equal to 1, what is 2 into 1? The value is 2. Okay. And if t is equal to 2, what is 2 into 2? 4. Okay. So here this value is t. So likewise it will be, that is, it is the double of the amplitude value. Can you understand? Okay. So this is the unit ramp signal. So unit ramp signal representation is R of t is equal to unit ramp. So the amplitude value is equal to 1. Otherwise the amplitude value may be different. So it may be 2, 3, 4, etc. Okay. So next is the unit impulse signal. Okay. So what do you mean by impulse signal? Means the del of t is equal to 1 for t is equal to 0. So for continuous time signal, del of t is equal to 1 for t is equal to 0 and 0 otherwise. So what does it mean? For t is equal to 0, the value of del of t is equal to 1. Okay. So this is t is equal to 0 and the value of del of t is equal to 1. And for del of n, the value is 1 for n is equal to 0. For remaining values, that is for t not equal to 0, the value is 0. Here also for n not equal to 0, the value is 0. Okay. So for del of n also, when n is equal to 0, the value of del of n is equal to 1. Okay, so this is for unit impulse signal. Normally the impulse signal can be represented as del of t is equal to infinity. That means, so if you are taking a small portion, you can represent this value as del and this portion as 1 by del, correct? So if del tends to 0 means what happens? It becomes infinity. So in order to get the unit impulse signal, we are compressing that portion. So it become compressing to 1. So it become 1. So next is the unit exponential signal. So what is a unit exponential signal? Means it can be divided into real exponential signal and complex exponential signal. Here also we are studying the unit exponential signal. So unit exponential signal, so x of t is equal to, normally we can represent it as x of t is equal to a into e power bt. Okay, normally we can represent it as x of t is equal to a into e power bt. So here unit exponential signal, so a value is equal to 1. Okay, so x of t is equal to e into e power bt. So based upon this b value only, we will get the exponential signal. If b value is equal to 0, so it is t and it is x of t. And if b value is equal to 0 means we get the DC signal. Okay, we will get the DC signal, that is one line. So it is the DC signal. If b value is equal to positive means we will get the growing signal. So it is the growing signal. If b value is equal to negative means we will get the decaying signal. So it is a decaying signal. It is the growing signal, and if b is equal to 0 means we get the DC signal. Can you understand? So for unit exponential signal can be expressed as x of t is equal to e power bt. Based upon this b value only, we will get this signal. So if b is equal to 0 means we get the DC signal. If b is equal to positive means we get the growing signal, and negative means decaying signal. And again, next if b value is, if you want to represent the imaginary value means this b is equal to j omega. You know, the j representation is based on the imaginary value. Okay, so it is the unit exponential signal. And next is the pulse signal. So the pulse signal can be either rectangular pulse or triangular pulse. Okay, so from the shape itself you can see it is a rectangular pulse signal. So what is the definition of rectangular pulse signal? Is x of t is equal to 1 for magnitude of t, modulus of t less than t by 2. Okay, so you know the magnitude of t represent, that is it ranges from minus t by 2 to plus t by 2. Okay, so the rectangular pulse signal, the value of this you are taking here, this it is the amplitude value. So if you are taking the unit rectangular pulse means the amplitude value a is equal to 1. Okay, so this is the definition. You must know about this definition. Next is the triangular pulse. So triangular pulse means the diagrammatic representation will be in this form. Okay, so it is a triangular pulse wave. So it is x of t and it is t. It is minus t by 2 and it is plus t by 2. So for minus t by 2 to plus t by 2, that is magnitude of t represent minus t by 2 to plus t by 2. What is x of t value? 1 minus magnitude of t by a. That is, by calculating this slope and this slope, we will get this answer. But you must know the definition. Okay, so it is a definition. So this answer is get by calculating the slope of these two signals. Okay, so study all these definitions. Okay, and next is the sinusoidal signal. It may be sine signal or cosine signal. You know, the value normally this signal will be represented in the form of amplitude and the cosine, cos omega t plus phi. Okay, so omega is the frequency and phi is the phase shift. So it is the cosine signal. Okay, it is the cosine signal and it is the sine signal. So what is the sine signal? The sine signal means waves will be passed through the origin. So here the cosine value has the amplitude value a. Okay, so I hope so it is all about the standard signal, or it may be represented as test signal. Okay, so using this signal only, by testing this signal we will get the sending the signal into the system and we will get the output response. Okay, so today we have studied about some standard signals. So what are the standard signal, unit step signal? So study all the definitions. Okay, so these definitions are important for doing the problem. So what is the unit step signal for continuous and discrete, and next the unit ramp signal, so for continuous and discrete. Okay, and next is for the unit impulse signal, and next is the unit exponential signal. Okay, and next is the pulse signal, sinusoidal signal. So students, study all this definition, it will be used for your problems. Okay, thank you.